Hello everyone, I hope you're doing well. I wanna present my accepted paper entitled A New 7-Level Grid Connected Converter using Model Predictive Controller. And this paper was prepared by me, Muhammad Abu Bakar and Bertilsson, all from Mid University, Sweden. The contents for this presentation are at first a short introduction about multi-level converter topologies and the switching strategies. After that, I will speak about our proposed multi-level converter topology. In section 3, I will explain model predictive controller, and after that I will present experimental and simulation results for our proposed topology, and finally short conclusion about this paper. In general, the multi-level converter topologies are divided into three groups: a diode clamp multi-level converter, flying capacitor multi-level converter, and a cascade multi-level converter. The first topology introduced for multi-level converter was diode clamped inverter. This topology consists of several input capacitors, diodes, and switches. The main disadvantage of this topology is balancing the input capacitors voltages, and also the number of required diodes is high. Flying capacitor multi-level converter uses many numbers of capacitors, and also the balancing is so difficult and needs a complicated switching strategy. Another type of multi-level converter topology is cascade topology, which consists of a series connection of several HPDGs. This topology suffers from using many DC voltage sources. In this slide, I want to explain the proposed 7-level converter. As you see in this figure, the proposed topology includes one input DC voltage source and two capacitors along with 9 IGBTs and one power diode, and you can see the switching diode and capacitor states of the proposed 7-level grid connected converter. According to this table, it is shown that the proposed topology can generate 7 levels at output voltage waveform, and also the proposed 7-level converter is able to boost the amplitude of input DC voltage source until 3 times, and this topology is a suitable topology for low voltage application because the uses switches in HPDs have to tolerate maximum value of output voltage. In order to control the injected current to the grid, we use model predictive algorithm, which is so fast and its performance is very good compared to other methods. In this method, at first the injected current to the grid voltage and output voltage of proposed converter is measured for all 7 levels. After that, by applying a KVL, we can get a cost function for this algorithm, in which the difference between the injected current to the grid and the grid current should be minimized, and after that we can get the switching pulses. As you see in this slide, the proposed 7-level converter is compared with other proposed multi-level converters. You can see that the proposed topology needs lower numbers of DC sources, switches, capacitors, diodes, and in comparison with some of these topologies, and the proposed topology doesn't require any transformer. The voltage on switches is lower than some topologies, and the proposed topology can balance the voltage on capacitors inherently, and also the proposed topology is able to boost the value of input voltage. In order to verify the performance of proposed 7-level converter, experimental results are provided. For this topology, the input voltage is 130 volts, switching frequency is 12 kilohertz, and other parameters used for our experimental works is shown in this slide. In this slide, in figure A, the output voltage waveform of proposed 7-level converter is seen that this topology can generate 7 levels, and also the waveforms of grid voltage and injected current to the grid is shown in figure B. This figure proves that the proposed converter can inject just active power to the grid, and also the voltage of capacitors are shown in figure C and figure D. That means the proposed topology can balance the voltage of capacitors inherently, and very nice. And finally, a short conclusion about this paper. In this paper, a new 7-level grid connected converter using model predictive controller was proposed that needs lower numbers of switches, DC voltage sources, diodes in comparison with other structures. In addition, the total voltage on switches of proposed 7-level converter is low, and in order to verify the performance of proposed 7-level converter, experimental results were studied. I hope this presentation to be useful for all you, and thanks all.